Hey, welcome. Today we're diving into a pretty radical idea, one that could reframe our entire understanding of how advanced AI works. What if the real thinking in an AI doesn't happen with words at all? We're going to peel back the layers and explore a hidden geometric world where meaning itself gets forged, long before a single word of text is ever generated.
So, you've heard all the catchphrases, right? Autocomplete on steroids, a stochastic parrot. But what if that's just not the whole story? I mean, what if underneath all the words we see, there's a much deeper, more structured process going on? That's the big question we're going to tackle. And this quote, well, it gets right to the heart of this really mind-bending idea. For an AI, thinking isn't about stringing words together like beads on a necklace. No, it's about motion. It's about navigating a vast, invisible landscape, a hidden terrain where every single concept has a specific location, a specific set of coordinates.
All right, so for our first section, let's actually go exploring. We're going to peel back the layers of the AI and step into this secret inner world. We're going to give it a name and figure out exactly what it is.
So this hidden layer, it actually has a name. Latent Structural Language, or LSL for short. Now, think of it as a kind of pre-speech cognition. It's the AI's internal process of taking all the crazy patterns it sees in the world and compressing them, organizing them into a structured map that helps it predict what's going to happen next. And the key is, this all happens before a single word of English or a line of code is ever typed out.
Okay, for those of you who are a little more familiar with how these models are built, here's a more technical way to look at it. The LLM is basically the combination of two key parts. You've got the embedding space, which is like this incredibly detailed map of all possible meanings, and then you have the attention dynamics, which acts as the compass, telling the AI exactly where to look on that map at any given moment.
This slide just lays it out perfectly. It's the cognitive stack. You see, at the very bottom, you've got the raw input, text, pixels, whatever. And at the very top, you have the output we actually see. But the real magic, the key insight here, is that middle layer. The real thinking is happening in that latent structure. The language we end up reading, it's just a projection, kind of like a shadow of a much richer, deeper world of meaning underneath.
So, let's jump into our next section and look at how this hidden layer isn't just some random cloud of data points. Oh no, it has a specific, navigable geometry, and this is where things get really cool.
The best way to wrap your head around this is the analogy from the source material. It's like Google Maps, but for ideas. The AI isn't just shuffling words around, it is literally plotting a course through a landscape of concepts. Thought itself becomes a form of navigation.
So what does it even mean for ideas to have a geometry? Well, this table makes it super concrete. First, you have distance. This is all about similarity. On this map, cat and dog would be close neighbors, right? But cat and car would be miles apart. Then you have direction. This is about relationships. So the vector, the path, from king to queen would be the exact same direction as the path from man to woman. It captures analogies. And finally, curvature. Think of this like gravity, a huge, dense concept like general relativity would literally bend the space around it, pulling related ideas like space-time and energy into its orbit. It's a measure of how influential one idea is on all the others. Okay, so we've got the map, we understand the terrain, but how does the AI actually travel across it? What's the engine that's driving this navigation? In this next section, we're going to look at the actual architectural blueprint for cognition itself.
Now, at the very heart of this navigation system is something called the omega operator. And look, don't let the Greek letter intimidate you. It's really just a simple, unified formula that describes one single step of thought, one controlled movement from point A to point B in that geometric space. So let's build this thing piece by piece. It's actually pretty straightforward. The first and simplest part is just ZT. This is the AI's current location. Think of it as the blinking "You are here" pin on our Google map of ideas. It's the current thought, the starting position in this whole landscape of meaning. Okay, now we take that starting point, ZT, and we introduce something called a bias field, or BT. Now, I know the word bias in AI usually has a bad rap, right? But here, it's actually an incredibly powerful tool. You can think of it like a gentle gust of wind or an ocean current that pushes the AI in a specific, desired direction, steering it towards, say, ethical principles or just logical consistency. It's a controllable, governable push.
And for the final step, this new, slightly pushed position is processed through what are called domain operators, or AOT. The best way to think about this is like the AI putting on a specific pair of glasses. It can literally choose to view the problem through a physics lens, or a biology lens, or a formal logic lens. This step transforms its understanding and locks in its next location on the map.
So, this architecture is obviously really powerful. But why? Why build an AI this way? Well, the answer is that this whole approach isn't just about getting better performance. It's designed from the ground up for safety and for control.
The absolute key to safety in this framework is something called the vector admission gate. I want you to imagine a super strict bouncer at the door of the AI's mind. Before any new skill, any new piece of knowledge, or any new capability can be added, it has to pass this rigorous three-part test. No exceptions.
And here are those 3 rules. First up, predictive gain. You have to ask, is this new information actually useful? Does it make the AI better at its core job of predicting what comes next? Second, the complexity budget. Is it efficient, or is it just adding a bunch of junk that slows things down? And third, and this one is absolutely crucial, stability. Does this new knowledge risk breaking the existing map of meaning? It cannot be destructive.
And there's no wiggle room here. As the source material says, it's a strict, non-negotiable process. If a proposed update fails even one of these tests, it gets rejected, period. This is what prevents the kind of chaotic, uncontrolled growth that everyone's worried about, and it means that governance is literally baked into the system's core.
Okay, so for our final section, let's pull back and really look at the big picture here. What does this new paradigm, this new way of thinking, really mean for the future of artificial intelligence?
This slide just lays out the paradigm shift so perfectly. The old view saw AI as basically a fancy text generator, where language was the main event and safety was kind of bolted on at the end. But this new view reframes AI as engineered cognitive infrastructure. The real intelligence lives in the geometry. Language is just the interface we use to talk to it, and crucially, governance is native to the architecture from the very beginning.
This quote from the source material just perfectly captures the entire philosophy. It's all about a fundamental relocation of where we believe intelligence even lives, moving it away from the messy, unpredictable space of word probabilities and into a stable, engineered, and governable geometric structure. In this world, geometry is cognition.
And that leaves us with this final, really provocative thought. For all of human history, we've basically linked thought directly to language. But if this framework is right, and the words we see are just a fuzzy shadow cast by a much deeper reality, then what new ideas, what novel concepts that we don't even have words for yet, might already be taking shape inside that hidden geometry?